Symposium. I give you a very warm welcome to all of you, and also this is on behalf of the other two organizers, Luisa Cifarelli and John Nimela. And as you know, this is a place where we have the Enrico Fermi School, so it's a very important historical place. And at the end of this week, we started the Enrico Fermi School of this year. So we start with some greetings from the authorities, the local authorities here. And I think I pass first to Mauro Manzoni, who is the mayor of the municipality of Varenna. And please, you can say something.
A tutti voi, la municipalità e la comunità di Varenna porgono il migliore benvenuto, liete e onorate di ospitare questo vostro simposio patrocinato da entità prestigiosissime, con temi pregnanti e cruciali. Confido abbiate potuto già rigenerarvi nella bellezza del borgo storico varennese, nonostante il caldo afoso, di questi giardini verticali e del panorama prealpino e lacustre di oggi. Eccovi subito un primo spunto come il rituale contributo per le vostre sessioni. Proprio qua, circa 20.000 anni fa, durante l'ultima glaciazione alpina, vi era una coltre di ghiaccio profondo 400 metri sotto i nostri piedi e alta 1.600 metri sopra le nostre teste, per un totale di 2 chilometri, mentre ora incalza una tragica siccità. Proprio qui, nelle contrade vicine, circa 6.000 anni fa, prima degli Etruschi e dei Romani, i Celti disponevano di un sapere scientifico, tecnologico e artistico che permettevano loro di tagliare e scolpire il duro granito e di produrre utensili da lavoro, oltre a speciali manufatti per la vita quotidiana e per le cerimonie. Ciò per immediatamente dedurre e focalizzare la legge generale che governa il creato, ovvero l'universo, il pianeta Terra e il genere umano, la legge della perenne evoluzione, con i due sottostanti paradigmi, relatività più progressività. Ne conseguono 3 basilari quesiti. Il primo: può esistere una conoscenza scientifica priva di dubbi e interrogativi? Secondo quesito: possiamo ipotizzare qui ed oggi un sistema di scienze realmente libero, indipendente e filantropico? Terzo quesito: il sapere scientifico in questi ultimi anni magari è stato assolutizzato e deificato? Nei circa 5 milioni di anni di evoluzione della specie umana abbiamo assistito a una sequenza ininterrotta di crisi e vittorie, con livelli superiori di civiltà collettiva man mano conquistati. Verosimilmente questo trend è destinato a continuare, benché l'odierno salto di civilizzazione presenti intensità, proporzioni, complessità e difficoltà drammatiche mai sperimentate prima. Pandemia, clima, conflitti, emigrazioni, sistemi politici ed economici iniqui e violenti, armamenti sempre più micidiali, informazione manipolata e compulsiva, relazioni internazionali antiquate e inadeguate, tanto solo per citarne alcune. Varenna vanta nitide benemerenze circa il progresso delle conquiste scientifiche e non solo scientifiche. Per brevità, occorre sorvolare su note figure storiche quali Plinio il Vecchio, Leonardo da Vinci, Antonio Stoppani, Marco De Marchi, già proprietario di questa bella villa monastero, Giovan Battista Pirelli, che proprio qui a Varenna ha avuto i natali, Luigi Scanagatta. Ciascuno di loro meriterebbe un approfondimento mirato. Veniamo invece ai decenni recenti e in questa cornice come non ricordare i 40 premi Nobel che proprio qui in Varenna hanno condiviso sentimenti e pensieri. Come non ricordare Enrico Fermi e altre eminenti figure che proprio qui non solo hanno discettato di energia atomica, ma anche hanno posto le basi per il Trattato ONU di non proliferazione nucleare, sancito giusto nel 1968 da 190 nazioni e la cui revisione è in corso proprio in questi mesi. Proprio qui Fermi, Conversi e Giannini nel 1954 crearono i presupposti da cui Avanzi, Faedo, Schiavinato, Perotto, altri scienziati e imprenditori, con l'Università di Pisa, insieme al CNR e la Olivetti, generarono nel 1959 la CEP e nel 1964 la Programma 101, computer elettronico italianissimo, primo al mondo, prodotto in migliaia di esemplari. Il filone dei profeti del XX secolo si è rivelato particolarmente affascinante, prezioso e fecondo. Lo studio e la celebrazione di varie fulgide figure connesse a Varenna ha permesso di conoscerne e divulgarne le virtù eroiche e gli adamantini talenti, riverberando ovunque il loro eterno retaggio, indicando col loro esempio che ciascuno di noi può intraprendere e contemplare il percorso e completare il percorso dell'eccellenza umana. Eccone alcuni: Giovan Battista Pirelli, già citato prima, Luigi Guanella, Romano Guardini, Teresio Olivelli, Adele Bonolis, Giorgio Lapira, David Maria Turoldo, Giuseppe Lazzati, solo per citarne alcuni e che hanno avuto diretti riferimenti a Varenna. Accanto a loro sono state celebrate anche persone sconosciute al grande pubblico, ma capaci di atti sublimi di coraggio e di servizio e solidarietà. Questo vostro simposio si svolge dunque in un contesto e in un momento storico molto particolare, con repentini ed epocali mutamenti a livello locale, nazionale e mondiale, evidenziando la fragilità di un pianeta e di un'umanità per lo più interconnessa e interdipendente. La globalizzazione avanza, incalza e sfida tutti noi, con drammatici contraccolpi sulla vita di innumerevoli persone, famiglie, organismi e popoli. Grandi responsabilità ricadono sulle vostre spalle e molto potete fare per il miglioramento delle condizioni del consorzio umano. In queste ore varennesi e nei mesi a venire abbiate come straordinario viatico coraggio, fiducia, entusiasmo, lungimiranza, creatività, sagacia, altruismo, desiderio di equità e di giustizia, solidarietà, integrità, leali spirito di squadra. Non esitate poi a riverberare i virtuosi convincimenti qui ed oggi maturati nelle vostre organizzazioni, nei vostri governi, negli organismi scientifici internazionali e nel sistema ONU. Vi auguro una vibrante consultazione e frutti eccellenti ai vostri lavori. Grazie.
So thank you very much for this very inspiring introduction. I cannot, I think to translate this is going to be a bit too long. What I propose, if you agree, to translate it and then put it on our webpage so that people, because it's very interesting, there is some history of the place, also of the geographical histories of the geographical let's say, conditions of the lake at the beginning. So I think it has very many interesting aspects inside. So if you don't mind, we can do that we translate it and then ask you the permission to put in our webpage so that our phone. So this was very well prepared, and it will take me some time to translate it and go through. And I think we don't have the time now, but we thank you very much for this nice summary of this, of the history of the place, of the people, also mentioning all the people that have contributed to the success of this, let's say, of the success of Varenna and all the cultural event around here. And the fact that also politicians and the mayor have very strongly supported this, and they are very proud of our work here, all the work here in the past and the work that we do now, from now on also. Okay, so this is what I think I can convey from this nice introduction. Okay, so now I introduce you Roberto Mani, who is member of the board of Camera di Commercio Como Lecco. So we'll say a few words.
Beh, intanto buongiorno a tutti, il mio vuole essere un saluto e un ringraziamento e mi sento veramente onorato di rappresentare la Camera di Commercio oggi davanti a una platea così prestigiosa. Vi porto i saluti del Presidente Marco Galimberti, del Consiglio Camerale e della Giunta, che in maniera unanime ha ritenuto di dover sostenere questo evento che si sta svolgendo sul territorio lariano. Sapete che la Camera di Commercio oggi è Camera di Commercio di Como Lecco e rappresenta tutto il territorio lariano, e in particolare evento che si sta svolgendo in un luogo di prestigio, in un luogo emblematico sulla sponda orientale del lago di Como. Quindi mi sento di ringraziare voi della presenza in questo luogo, mi sento di ringraziare gli organizzatori che hanno scelto questo luogo perché si svolgesse questo evento, l'ente provinciale proprietario della villa in cui ci troviamo, della struttura in cui ci troviamo, il sindaco ovviamente, che con una prolusione davvero interessante ci ha esplicitato anche la storia del luogo in cui ci troviamo, per cui un arricchimento notevole. L'occasione di questo incontro è la celebrazione dell'anno internazionale delle scienze di base per lo sviluppo sostenibile, evento che troverà poi il suo culmine negli incontri di luglio e di settembre a Parigi, in Serbia, dove evidentemente si celebrerà in maniera propria questo anno internazionale voluto dall'ONU, dalle Nazioni Unite. Le scienze di base hanno accompagnato da sempre la storia dell'uomo e ne hanno consentito il progresso, consentono la conoscenza della natura e consentono quello che noi oggi chiamiamo progresso e sviluppo. Credo che oggi sia sotto gli occhi di tutti che il modello di sviluppo che sino ad oggi abbiamo adottato e ritenuto giusto debba trovare necessariamente delle modifiche, debba essere cambiato, ricostituito, rivisto, e ovviamente le scienze di base hanno oggi anche questo compito, cioè di rimodulare e di dare suggerimenti ulteriormente per modificare il nostro modello di sviluppo, almeno nell'ottica di garantire le generazioni future su quello che noi abbiamo avuto, almeno su quello che noi abbiamo avuto in dotazione. Quindi in pari modo che le generazioni future abbiano a loro volta le risorse, siano garantite loro le risorse che noi negli ultimi 50 anni abbiamo avuto per garantire il nostro sviluppo. Quindi credo che il vostro lavoro sia fondamentale, sia una sfida non da poco, e nell'ottica di un progressivo avanzamento delle scienze vi ringrazio per il lavoro che fate. Grazie.
Okay, thank you very much. Thank you very much. So also this one will be in any case on streaming. So if you want to write something, we can do the same and put it on our webpage. We translate and put it on our webpage. Okay. Okay, so now I have also some other word greetings and some welcome word, let's say, from Engineer Vico Valassi, who is the president of Univerlecco. So I just, he wrote a very nice message. I try to, let's say, to read it, but also summarize a little bit. Engineer Vico Valassi is welcoming us to this symposium that takes place at the same location where we have the Enrico Fermi International School of Physics, as I mentioned at the beginning. So he thanks myself, but in particular also Professoressa Luisa Cifarelli, who was the former president of the Italian Physical Society. And is very pleased to bring his greeting from, on behalf of Univerlecco. And of course, he realized that this period of COVID has created difficulties to everyone, including that university. And now it's important to go back with events that are organized with the real presence of people. Univerlecco has supported the implementation of the courses here since 2016 and strongly believes the importance of training and updated on issues that embrace new frontiers and discoveries in physics. He's very pleased to remind us that Lecco is a very fertile area for research, training, and innovation. The campus of the Polytechnic of Milano Territorial Pole of Lecco, which is located in, of course, Polytechnical is located in Milano, hosts teaching, research, and has a residence for 2,000 students, and 25 to 30% of which are foreigners. There are 23 research laboratories. Then they have 5 square meters dedicated to Polyhub, sport, and very important equipment also for the student. I like to point out that this pole of Polytechnic di Milano was the, let's say, the test bed for the education in English. So all the courses were given in English in the last 15 years. And so for that, it has seen 2,200 foreigner students from 90 countries. And this all graduated there. So there is also a coexistence with the National Research Council, that is CNR, that has 7 institutes and laboratories in the Unilecco. So Polytechnic of Milano and CNR have been collaborating for years, thanks to the coordination of Univerlecco, and also the precious funding obtained from the Lombardy region and Cariplo Foundation. So now there is also some involvement in creating a rehabilitation district. So, and this started in 2017, and there is a collaboration with INAEL to operate this rehabilitation district. Then the Lombardy region has asked Univerlecco to coordinate the Lombard technological cluster for living environment, with which issues that are treated there concern home remote monitoring, sensor and technology, and this all have as an aim the improvement of the quality of life, of people. So I think this, the collaboration between the campus and the various institutions here are very, let's say, effective and fruitful. And I think this will continue in the future with excellent programs. And I think let's say the support for us with this, with the schools and with this special event is highly appreciated by us. There is also some funding, some support that comes from there. And I think we recognize this as an important contribution, not only, let's say, material contribution, but also intellectual contribution for our schools. So thank you very much for this. If you want to stand up, Engineer Valassi is here, that if you want, then during coffee break, I can introduce it to you. Okay, this is so he has been very, very active for the local environment here, and also has given a continuous support to us, and this we appreciate it very much. Okay, so with this, I think we have concluded this introduction, and I thank you again, and thank you for this. Can you leave the? Yeah. Can you leave the talk? Okay. Okay. So we thank again the mayor, Mauro Manzoni, and Roberto Mani, also for supporting us. He's also supporting us for the schools and for this particular initiative. Thank you very much to all. So now we can start. And let me say, go back here. So we have we have now some word, introductory word, expressing in a very short way, unfortunately, what the various institutions, Italian research institutions, sees this initiative and what they are really doing already in connection to this basic science for sustainable development. Now, I think the first one is connected now, is Corrado Spinella, who is the responsible or the director of the physics part of CNR. And I don't know if he's already connected, otherwise we can change the order. What is the situation? We have to be a little bit patient. We have 3 short talks from distance, and the other are present. So what do we do here? We have to. Is somebody knows if Corrado Spinella is connected? Com'è? Because we are a bit earlier as compared to the. We were supposed to end in 10 minutes from now. So maybe if you don't mind, what do we can change? I think we are flexible. We will not hurt us if we change a little bit. So we start with Gabriele Zanini from Enea, who is a research director responsible for part of, let's say, of the research that you will describe to us. Okay, so we do this. Sorry, this is that is a bit.
Hello, good morning to everybody, and many thanks for this invitation. I bring you the greetings and thanks from my president, Gilberto Dialuce, and I am very happy to be here representing Enea and our passion for science. We have more passion than money, but this keeps us young and strong. So it's very interesting that after 2 years of pandemic, you choose for this symposium to combine passion and basic science for sustainable environment. I think the reason call us to be pessimistic given the situation all around us. And on the other side, passion pushes us to find a new solution for politics and for citizens in order to be prepared for climate change adaptation and to explore new paths towards the decarbonization of our society. I just show you 3 major research teams we explore in the last few years in Enea, connected to the sustainability. Enea is a research and development organization funded partially by the Ministry of Ecological Transition, and it deals with energy, nuclear technologies, environment, ICT, agri-food chain, and so on, and also enabling technologies. We are more or less 600 researcher and technician, and we are spread all over the country. The main center and the headquarters are in Rome, and you probably know the research center in Frascati, where and in Casaccia near Bracciano. I'm coming from Bologna. This is a free example facing global challenges. Virus and particulate matter. Is particulate matter a carrier or a booster respect to the virus? We have had a long polemic season around this topic. Climate change, Mediterranean region is an hotspot, which means that in this region, the risks related to the climate change is harder and deeper and faster. 2 regions in the world are climatic hotspot, the North Pole and the Mediterranean region. And also exploring renewable energy potential using the same instruments you will see next. Virus NPM, booster or carrier? We developed a molecular modeling using high-performance computing. And, you know, the layers, these layers are the structure of graphene, simulating the carbonaceous part of particulate matter, and the other molecules are ammonia, sulfur, and so on, all the components of normal particulate matter in our atmosphere. This is supposed to move. Okay. It doesn't move. Okay, this is the interface of the spike protein of the viruses with our particular matter model. And without moving, you cannot understand the complexity of the system. Okay. This is a 260 nanoseconds simulation, and it serves 600 CPUs computer in high-performance computing center. The 600 CPUs run for 4 days for 260 nanoseconds of the simulation. But this is a promising techniques to understand the connection between viruses and PM viruses and molecules in atmospheric pollutants. Climate change. 6 days ago, we gathered the ensemble modeling system of Copernicus atmosphere system. Is the big initiative of the European Union for observing Earth and space. And our model, Mini, is after 2 years of test, has been part of the 11 European models giving the forecast all over the Europe about air quality and sarin dust and so on. We succeed in simulating this huge episode of sarin dust during last March, where in Spain we monitored the concentration beyond the threshold limit of the instrument. So it is a very strong episode of sarin dust, and the models simulate very well the situation. And also, this is supposed to move. This is our climate model. I detailed climate model over Mediterranean Sea, because in the details are the il diavolo, and we adjust the detail of the Earth circulation model to apply to the Mediterranean Sea. In fact, the resolution is 230 meters in the two straits, here, Gibraltar and Turkish straits. It's very important in order to communicate with Atlantic Sea and Black Sea. This is the evolution of the temperature in okay. The evolution of the temperature, no, this is the sea level projection. So look what's happened in the Adriatic Sea around Venice, because in a time in which the sun of our sun would see Venice, probably Venice will be flooded by the Adriatic Sea, because these are picture about the flooding areas in the 2100, and you see that all the coast between Ravenna and Venezia are at risk of flooding, so the sea enter in the land for 80 centimeters. It's a very huge picture. And finally, the same, this is the area interested by flooding. And with the same model, we explore renewable energy potential. We applied for example, in Africa, in Lesotho. This is a very small and complex, orographical complex site, and we calculated the wind power density and the solar power density for exploiting renewable energy in those countries. Is very important because they have to abandon gas line and to use wind and sun. And finally, we use the ocean model in order to cite the best, to find the best site in order to pose this pendulum wave energy converter developed in collaboration with Politecnico di Torino. And is simple because it's based on the movement of a pendulum, and the movement is converted in energy. So the model used to find the best site in order to put the converter. This is an example of how to produce energy from the wave, sea wave. So that's all. Thank you very much. Sorry for the moving, not moving. Thank you very much.
Maybe we can discuss with you also during the breaks.
Okay.
Because the idea is just a lesser suburb than maybe also in person. Otherwise, we will move to the... Okay, but this was a very nice example. Very good research. Okay, now I think I need a microphone. I mean, you can hear me, but I don't know when people are connected. So is the connection for Corrado Spinella ready? According to what I understood, it is.
Yes.
Okay, Corrado.
Thank you for the invitation.
Okay, I introduced you before, so please go ahead.
Okay, so I have a short presentation that I can show you, so I try to... Can you see?
Yeah.
Okay. I hope so. Okay, thank you again for the invitation and for discussing together so important subject, the role of fundamental science in solving the future challenges of our society. Actually, I think this is an important breakthrough, and this is particularly true for the role played by the National Research Council of Italy, and particularly by the community operating in the field of physics of matter. I am the director of the Department of Physical Sciences and Technologies of Matters in CNR. Our mission is shown in this view graph. Our ambition is to shorten the distance from basic research to technology applications. So our activity moved from investigating the fundamental properties of advanced materials, semiconductors, superconductors, oxides, novel materials such as 2D materials, graphene-like, and so on. We use advanced characterization techniques, and we try to realize prototypes for a large number of applications. I will show you some example of these, and such developments are carried out in proper laboratories, essentially clean room, this development activity is finalized to the realization of complex device that eventually can be important for market applications. Okay, this essentially is an example of our capability in terms of state-of-the-art analytical techniques. Here you can see our atomic resolution microscope installed in the facility we have in Catania, operating in the field of microelectronics. This instrument is the only one in Italy that has a resolution that is below 1 angstrom. So we can see directly this atomic structure of materials. No simulation. We see directly in the matter. And also we have the capability to solve the spectroscopic nature of the bonding states of the matter that we can observe with this instrument. And again, here you can see also our clean room, that is a class 10 clean room. It is compatible to microelectronics applications, so we work by exchanging wafers with the semiconductor industry. So we are ready to transfer our idea to technological application very soon. Okay, just an example that I can show you that is important for the green transition. Microelectronics is very strategic in this field because essentially is the technology that will enable the electrical transition. In the future, we use a large amount of electrical power generated by renewable source. And for this aim, it is essential to use an efficient technology that allows us to manage the electrical power. And this is possible moving to beyond silicon semiconductor microelectronics. So novel materials, novel semiconductor. Here you can see some example of these. Silicon carbide, gallium nitride are the future material that will replace silicon in this kind of power electronics. It is the power electronics that will enable the transition to a complete electrification of our energy users. So we think that in the near future, the drastic reduction of CO2 emissions actually can be realized by an increase of the efficiency in the use of the power the power source. This is a specific example. Power electronics will will be present in the electrical vehicles, especially for converting the power generated by battery to the engine. But not only, there is also the smart power. So that is to say, the power that is necessary to light or to electronic function of the future vehicles. Here it is shown an example of how we operate, actually, the example of the silicon carbide technology. This technology 10 years ago was considered pioneeristic. And this demonstrates how it is important to start the activity inspired by passion and paying attention to fundamental physics. Now, silicon carbide is a mature technology that was transferred for application to, in that case, ST Microelectronics. Of course, we are investigating novel material and heterostructures. Here you see the example of integration of 2D materials on wide bandgap semiconductors. This is an important activity, fundamental science again, but it is a reach of many perspectives because we can join the advanced properties of novel semiconductors, wide bandgap materials, with what we expect in terms of functionality from 2D materials. So the hybrid integration, it is a promising technology. Also, we have a strong activity in the field of renewable source, for instance, photovoltaics, and especially for photovoltaics, again, we are investigating novel materials, in that case, perovskite, and again, the approach is to project an hybrid structure in which we can integrate novel materials, perovskite, with the well-matured technology based on silicon in order to get the maximum efficient in photon conversion and photovoltaic efficiency. Finally, I would like to conclude my intervention by showing you the approach we follow to storage energy generated by photovoltaics. We are working again on developing material and nanostructures to make efficient the conversion of the photovoltaic power in for generating hydrogen, so the green hydrogen. And here I hope to be more like in the movie. I think you can see our prototype. You see the generation of hydrogen coupled with a bifacial, in that case, a photovoltaic panel built by novel silicon technologies. Thank you for your attention.
This is really excellent research, and our society will benefit for sure.
I think so.
Let's hope in few,
I hope so.
Let's hope in few years, not very long. Okay, so thank you very much again for your intervention and for giving such an interesting example of this high-quality research you're doing there. Okay, so now I propose another change in the program because of connection and related issues somehow. So we go now to Diederik Wijsma, who is the president of the Institute of Research in Metrology. and is already connected, so the floor is yours. Please, Diederik. Can you hear me?
Hello, can you hear me like this?
Yes, yes. So you're there.
Hello?
Yeah, hello?
The audio just went away.
Okay, so please, we can hear you. Hello?
I cannot hear you anymore, but if you can give me a sign that you can hear me, then I can continue.
Yeah, we can. Yes, we hear you. I don't know.
Okay, excellent.
Right.
So, it's really, I'm really sorry for not being with you, because Varenna is maybe the most beautiful place and the best physics school of all places. Of course, Italy is very strong in that, and I think Varenna is really a lovely place. So I'm sorry for not being there with you in person, but I wanted to share a few slides. And this is about the science of measurement, so metrology research, and within the context of a sustainable world, of course. And this is the entrance of our campus of the National Metrology Institute in Rim, very early in the morning. Now, the measurement, science of measurement means that, let's say, you have to measure things accurately, and you have to measure things in a reliable way. And that is a problem, let's say, everywhere. It's a problem in daily life, it's a problem in industry, and of course, it's a problem in scientific research in general. And I wanted to share a few thoughts about that with you, what is happening in that context, and what we can do as metrology research for the topic of a sustainable world. Now, many of you will know that there has been a recent change in the system of units of measure. So we have the SI, which everybody is using every day, and but many people may not realize that there's a lot of work in getting this, getting agreement on the international level what the SI actually is, and what we should use as units to measure things. And there has been a recent international conference where all the countries that adhere to this SI, they come together and they vote on the new system. And this was just a few years ago, and the new system is now very beautiful also from the point of view of the fundamental science which is behind it, because we have these 7 fundamental units, of course, the kilogram, the second, meter, ampere, candela, Kelvin, and the mole. And they make a reference now to the natural constants. So here's Planck constant, the Boltzmann constant, etc. So as you measure anything, you need something else as reference. And now the natural constants are used as reference for our system of measurement. In the past, of course, this was done by using objects. So the kilogram was defined as a block of material which was somewhere in a safety box, let's say it was securely stored away, and people would go there from time to time to calibrate their instruments, but it was based on a physical object, which is very much not elegant and also very much not accurate. So this has been substituted now by using natural constants. And the best way to explain how this is possible is if you take, for instance, the Planck constant, and you realize that the Planck constant over here, this is h, is what you need to relate the energy of a photon with its frequency. So if you measure frequency very accurately of a photon, then you have the energy of this photon. And of course, through Einstein's general relativity, we know that energy and mass are equivalent. So then you have a unit of mass. By defining and measuring accurately and then defining the natural constant, you can measure the frequency of a photon, you have its energy and thereby its mass. And it is really like this. So you would have an atom or a particle, and then you would measure its mass, its weight, and therefore its mass. And then if this emits a photon, after it has emitted a photon, it will be slightly lighter, so there will be slightly less mass. And that is now what we use as the new reference for measuring mass. So I think that's very beautiful. And of course, the other units, they were already done in this way. Now, why is this relevant within the context of sustainable energy? Well, to start with, to measure things, you need units of measurement. So you need to have an SI, and this has to be working properly. But now that things are working properly and we have an excellent SI and everything is working fine, the next step, what is the next step? Well, there's a lot of incredible technology to measure things accurately and to measure things in difficult situations. This is an example of the Kibble balance, for instance, which is used to compare the mass of a physical object with this new definition of the kilogram. And like that, there is an enormous amount of technology available which can be used for many things. And there's know-how how to measure things accurately, as I said before, also to measure things in a reliable way. And that is increasingly important, that you measure something and that people can trust the outcome, that it is not biased by, let's say, opinions, or that it is biased by political will to go to the left or to the right or whatever, or forward or backward, but that a measurement is a measurement and data is data, and it is clean data and it is reliable data. This is so important to have that, and I think metrology research can contribute to that. And what we think and what we're really working on, I will give you now 6 slides of examples of contexts where metrology research can play a role and is playing a role and will be more in the future, and then the talk is finished. So the first is the topic of monitoring the environment and to develop, to support the development of clean technologies. So we will play a supportive role. So we will not develop all these technologies as such, but by, let's say, providing the technology for doing accurate measurements, we will be supportive in this. And that is, for instance, by that comes out of the data of satellites and terrestrial sensors, etc. But also taking data. This is one of our missions where we go to a complex environment and make sure that even if you're in a very cold or very harsh environment, the data that you're taking is taken in a proper way. And then there is, of course, the impact of consumer products, including its production. Think of this. So nowadays, when you buy something in the supermarket, you will have a label where you have some information maybe on the plastic and that is used to make the bottle and things like that. But one parameter that is missing is when some food or some product is made, there will be the impact, also the environmental impact of the production process as such. And this production process will also give pollution. So there should be a number on the label that tells you if the producer, how much the producer has polluted when it made the thing that you're buying. And then you can compare 2 products and you can choose to buy the one where the producer actually has polluted less. This is an example of where you need a parameter that is reliable, that has to be measured in some way, that has to be understood how to measure that, and that can be very useful for the consumer. It's an example of science of measurement, I think, in daily life. And then there is sustainable energy and conversion, and a clean storage, of course, of energy. Storage is, of course, a very important topic. So we will not be able to develop new batteries, but we'll be able to help you to define the right parameters that you should measure on these batteries and to measure that in a proper way. Solar cells, it is important to, when you develop a solar cell, that you understand its expected lifetime. So you should be able to develop a parameter or a procedure in which you measure these solar cells and you predict their efficiency out of real measurements for the future. The same is done for semiconductors. Can you do this now for solar cells? And so on and so forth. Then we have the context of the quality of life and health. I will give you a nice example, for instance, of food. If you buy some food, it says on it that it is organic, but can you be sure? So you should do measurements that you actually can certify that the producer has not been cheating on you, that it has actually been produced in the region of the earth where it was claimed that it has been produced, and that it was really produced in an organic way. And you can do similar things with food packaging. How much is the food packaging polluting your food, and how much pollution has been generated by making the packaging, and so on. Then there are a lot of things going on, of course, in our industry. what is in Italy also referred to, and in some countries referred to as Industry 4.0. It has to do with the digitalization of industrial processes, sensors, neural networks that will take decisions made by robots. So a robot can produce an electric car, like the Tesla factory is totally run by robots. And these robots, they take decisions made from sensor data. And even if something goes wrong because a robot will break down, there are sensor data which will predict already that tomorrow a robot is probably going to break down. So you will go and you will do maintenance before that happens. Now, in that data, you want to make sure that nobody is cheating, and you want to make sure that the data is accurate. An example of that was, of course, Volkswagen, who was cheating on their pollution data, which was all in all the newspapers some time ago. But you have similar things. So this is now not measurements done in the real world, but these are measurements done in the virtual world of digitalized data and large amounts of it. Now we're getting number 5, space. So Copernicus is, of course, as you saw, seen already before, related to Earth and environment measurements. And the Galileo navigation system. I'm now at the moment in the Netherlands, and I've just visited ESA, where there's a lot going on the Galileo navigation system. And I was proud to say that the time signal to run the entire Galileo system is coming from Turin, so it's coming from Italy. So the time system, the timestamp, let's say, that is used to make the navigation system work of the Galileo satellites all around the Earth, that's an Italian time signal. And that's, of course, because a navigation system needs a very, very accurate timestamp. If not, it doesn't work, because that's what it's all based on. And then there are things like quantum key distribution, etc., that are all going to go through satellite systems. And then the last one, and maybe the one which is kind of more special to our metrology research compared to that in other institutes in the world. Our metrology institute in RIM is, let's say, very close to fundamental research. It is also financed by the Ministry of Research, while in other countries it is usually financed by the Ministry of Economic Affairs. So that means that our science of measurement is closer to other fields of research. And I think it is very good to have synergies between metrology research and other fields of science and fundamental research. And people can learn from each other. So fundamental research comes up with a lot of ideas to measure new things, and maybe metrology research can help to do these measurements in accuracies that can go up to 8 or 9, 10 digits, which is really an amazing effort. And with that, I've come to the end of my talk, and I thank you. And really, I'm so sorry not to be with you in Varenna, but I'm sure that you're enjoying, and you will enjoy the conference, and you will have a lovely time there on this topic.
So thank you very much for this nice summary of the important research that you're doing, and which is also very well connected to the theme of this symposium. And so let's hope that next time you are able to come in person here. So thank you very much again. It was a very nice summary. Thank you. Okay, so now we go back to normal. Okay, so normal. So the schedule. So the next one to come is Diego Bettoni, who is in the management board of INFN, and he will say a few words. And he was former vice president also of INFN. So, sorry, I say INFN, but most of you, INFN is the National Institute of Nuclear Physics. I think most of you, sorry, I just don't spell out, but I guess most of you know. Okay.
Grazie, Angela. Thank you, the Italian Physical Society, for organizing this workshop, this symposium on passion for science. And thank you, Angela, for inviting us. I will bring you the greetings of the president of INFN, Antonio Zoccoli, who unfortunately could not be here. So as you know, we are the Italian research institutions for nuclear physics. We are about 2,000 people, 1,000 researchers and technologists, and 1,000 between technicians and administrative people. We are spread on the Italian territory. We have headquarters in Rome, but then we have 20 institutes, the most important physics departments at Italian universities. We have 4 national labs in Legnaro, Frascati, Gran Sasso, and Catania. And we have 2 technological research centers, one in Trento and one in Bologna. And then we have a theoretical research center in Firenze. Our passion for science is for the big questions of fundamental science. So what is matter made of? What forces keep it together? How did the universe originate? How did it evolve? What happens with namely the formation of the stars, and where is dark matter, where is dark energy? And these are the big questions which make for the passion for science of our researchers and technologists. So as you see, it's basically the basic mission of INFN is fundamental science. So how do we conjugate this passion with facing the global challenges, and which is the title of this workshop? Well, our main areas of our way to cope with the global challenges and to make a contribution is basically to apply, to transfer the technologies that we develop for our fundamental studies to fields of application. What Corrado said before, bringing technology, science closer to technology and technology closer to society. And some of the applications have a significant impact on sustainability and facing the future challenges of the future. I will make a few examples. So one of the technologies that we employ to do our research are accelerator technologies. And these field of accelerator technologies also have, we can apply these technologies to fields such as energy, for instance. We collaborate with ENEA on various fusion projects. There is a major project which is now the diverter tokamak test, which is led by ENEA and with which INFN contributes. And we participate in this project because of our competences in the development of accelerator components. And these are projects which are aimed at developing fusion, which is an alternative form of energy, which maybe is not green in the typical sense, but is certainly a form of nuclear energy, which is, if successful, is going to be very efficient and without the problems of conventional nuclear power. And we participate in other programs of fusion energy, the IFMIF, EVEDA, and next the IFMIF DONES projects, respectively in Japan and Spain, which are projects aimed at studying materials for fusion reactors. And again, our contribution is in the field of accelerators. Another project which was recently approved and which will be funded by the PNRR, the National Resilience and Recovery Plan of Italy, is also in the field of accelerator technologies, and that's the IRIS project, Innovative Research Infrastructure for Superconductivity. And the idea is to build, as I said, a research infrastructure dealing with superconductivity. The origin of this, the main motivation, of course, comes from the necessity to find to develop new cavities and new conductors, superconductors for the accelerators of the future. But of course, this will have also a big impact on the transport of energy for normal use, because it will basically provide a unique test bed for facilities which are able to transport large amounts of DC currents with very, very small dissipation. Another field in which we are strong is computing. because of the very large amount of data which come from the LHC, the Large Hadron Collider at CERN. We had to develop a very strong computing infrastructure, which is also distributed in Italy, which has a major node in Bologna with then 9 additional nodes in other Italian labs of INFN, so over the Italian territory. And because of our competence in computing, we were the proponents of one of the 5 national centers of the Recovery and Resilience Plan, which is the National Center for HPC, Big Data and Quantum Computing. And there, the center was approved and it will be funded with approximately 320 million euros. This is a large partnership of INFN with Cineca GAR, which is the network infrastructure of Italy, and then other 49 public and private partners. There is ENEA, there is CNR, there are major Italian universities, and also, as I said, private companies. And of course, computing in itself is not green, but one of the goals of this project will be also to find the solutions with a very green power user efficiency. That means to find the solutions both in terms of green hardware and also through the development of algorithm to optimize energy use, and so to make this to give to this center as green a footprint as possible. Also, one of the areas of activities of this research center will be quantum computing, and quantum computing is in itself a more energy efficient way of doing large computations than regular hardware-based classical, let's say, computing. Next, I will also mention that we have lines of activities in which we apply, again, our technologies, mainly in the accelerator, but also in particle detectors development to environmental studies. And so we have these projects which studies something similar to what the colleague from ENEA described, in which we studied the correlation between virus developments and atmospheric pollutants. And also INFN is part of the Italian node of the Actris facility, which is a European research infrastructure devoted to atmospheric studies. Finally, I will mention also that we have a collaboration with the CNR on another national center, which is the National Center on Biodiversity. And there we participate through our laboratory in Catania, the cube kilometer array, which is devoted to neutrino studies, but which also has the possibility to be basically an observatory of marine biology. And so this is a collaboration that we have with CNR. CNR is the proponent of the center, which will be in Palermo. And this is another contribution of INFN to facing the future global challenges. So you see that even though our mission is very, very far away from the topic that we are discussing today, the application of our technologies and the passion that our people have developed also for these technologies allow us to give a significant contribution to these, to discussing these matters. So this is all I had to say, and thank you very much.
Thank you very much, Diego, for this nice overview of INFN that still does put a lot of effort in this kind of more applied activities. Okay, so now I think it's time to go to the Italian Institute of Astrophysics. So this is Patrizia Caraveo, who was appointed by the president to represent or to give us a short overview of the Institute. And I just want to say that Patrizia just recently, last year, received from us the prestigious prize Enrico Fermi.
Thank you. So I'll be very good. Thanks. Talking about astronomy done by INAF, National Institute of Astrophysics. And we, of course, do astronomy for the fun of it, because we love to study the behavior of celestial bodies, but we also develop technique, instruments, then can be useful for a number of different dimensions in different fields. So INAF is an institute in a way similar to INFN. It's spread all over Italy with 16 centers and observatories, since the institute was born to put together the historical observatories and the very new centers which were born to study a new kind of astronomy which became possible in the last half century through space exploration. So we do astronomy from the ground and from space. So we have a very, I would say, if you want, complete from different perspective view of the sky. And we have an extensive development of instrumentation to study the sky. The Institute encompasses 1,200 people with permanent position and more or less 400 with temporary positions. There are all the postdoc of various levels that are essential for our research and our success. So now let's focus a bit on a view of astronomy for sustainable development. What can astronomy do? First of all, one of the pillars of sustainable development is open science. So astronomy is a very open science. I used to joke and say that we are the most democratic science, since you look at the sky and you see the star. The sky is a very powerful inspiration for people, especially for younger ones, to get interested in science. So the sky, it's provide a very good leverage to teach science in a fun way to students. For a more professional use, all astronomical data are openly available. either immediately. There are instruments that provide immediately their data to the public, and they also provide the tools to analyze them. Other instruments provide the data through freely reachable archive system after a few months, up to a maximum of 1 year. So the astronomical archive are a very powerful asset for everyone interested in doing science. Astronomers are full of fantasy, full of enthusiasm, and they invented, I claim, citizen science. The first project of citizen science was Galaxy Zoo. Galaxy Zoo was launched from University of Leeds, I guess, to ask the help of people, of citizens, so people with no training, to classify galaxies. Has been an enormous success, absolutely, and Galaxy Zoo has become an example, has been replicated a number of times. If you search the site Galaxy Universe, you see an unbelievable number of projects. Sometimes astronomers do not have enough money to do what they would like to do, and so they have invented the computer, the distributed computer power through SETI at home. Now there is Einstein at home. There are a number of other ways to ask to the people the permission, if you want to use the power of their computer when the computer is idle. So SETI at home has been used by more than 5 million people. I mean, has been a huge success. SETI, the search for extraterrestrial intelligence, has not been found yet, but we are still searching for it. And the recent news about the Chinese telescope seeing something extraterrestrial is most likely an interference. Astronomy for public health. We have been asked by enough management during the pandemic, can we do something to help? And the answer has been yes. We are experts on every kind of radiation, and as a matter of fact, we are experts on UV radiation. UV detector, and so we, together with the hospital in Milano, the hospital Sacco, which was deeply involved in the pandemic, developed lamp to be used to sterilize the air in ventilation system in public building. Astronomy for everyday life. Ladies and gentlemen, every time you take a picture with your phone, just think to the astronomers who have developed the CCDs, which is on the heart of all phone cameras. And the same is true for Wi-Fi. Wi-Fi were developed by radio astronomers. So, I mean, we think that astronomy, which study faraway objects, is absolutely fundamental for everyday life. Also, astronomy is a science for peace, since we do everything in big international collaboration. and we suffer very much for the crisis we are going through. And last but not least, we are very well aware of the carbon footprint of all our observatories. For instance, the observatories up in the Andes, in the Hawaii, in La Palma, etc. And so we are very concerned about it, and we try to limit travel through remote observation. A lot of our telescope can be controlled remotely. And this was done before it became fashionable to compute the carbon footprint. And one last point, astronomy uses satellites. And it's very concerned now for the potential threatening situation we are facing in the low Earth orbit. Why so? Why astronomers are concerned about satellites? Because we see this kind of picture. This is a nice comet, New WISE, last year, and you see these very many strikes. These are the Starlink satellites by Mr. Elon Musk, which became a benefactor of humanity thanks to his effort to help Ukrainians to have internet connection, but is also filling the sky with satellites. Satellites, this is the number of satellites launched from the beginning of the space age up to last year. And you see the dramatic rise, and the rise is more or less totally due to the launch of Starlink satellites. Everything does have permission. I am not claiming that Elon Musk is doing something outside the law. The problem is that there is no law to somehow rule or regulate the number of satellites that can be put in orbit. Right now, there are, for instance, 2,000 Starlink satellites. Musk has permission to launch 1,200, and there is another permission to launch 30,000 more. I mean, it's a lot. And so the real problem astronomy is telling you to be aware of is the problem of orbital traffic jam. We are really facing a problem since our life depends on the use of satellites. We cannot just leave the orbital around Earth to be too crowded. And so if an orbit contains too many satellites, the risk of bumping in each other is very high, and this starts what is called the Kessler syndrome. And we cannot allow this to happen. And I finish with a little self-promotion, since I became aware of this problem by writing a book on star pollution. As I said, astronomers are concerned about every kind of pollution of the sky, and the satellites are polluting the sky, the astronomers' sky, but they are really polluting everyone's sky. And so we just ask very strongly to the United Nations to do something to regulate the orbital traffic. I do not feel embarrassed to show you my book, since I guess all your institutions subscribe to some kind of Springer link, and this is freely available on Springer link. Thank you.
Thank you very much, Patrizia, for this nice overview. And of course, we have a Springer link also with the Italian Physical Society. So I suggest you to read this interesting book also. Okay, so now we conclude this part with the president of the National Institute of Geophysics and Volcanology, Carlo Doglioni. I don't know if he's connected. Is it? Okay, I have introduced you, Carlo. So can you hear us? Can you hear me?
Yes, I can hear you.
Okay, so we can hear you, and then so you can start your short presentation. Thank you.
Oh, thank you. Well, first of all, good morning, everybody, and many thanks to the President, Angela Bracco, for this invitation to give a very short greeting. I have now not a presentation like the other scientists. Well, these days we are facing very incredible challenges. The weakness and at the same time the strength of, and the importance of peace, the global warming, the energy supply, the economic and health differences among people, the natural hazards. Well, one general comment is that everything in nature, every phenomena is determined and controlled by some type of gradient, whether it's pressure, temperature, electrochemical, but also socioeconomic gradients, demographic gradients. Well, as INGV, which is the National Institute of Geophysics and Volcanology, we are trying to have an organization similar to INFN and INAF that were presented before. And we have three departments, one studying earthquakes, the other volcanoes, and another which is devoted to the environmental development. So we are working in studying natural risk for a more friendly relationship between the human being and the earth, because in order to be prepared for the next earthquake, to support population for recovering and finding new energy, to study the earth, to study the mechanism are fundamental. So earthquakes, volcanic eruptions, environmental pollution, geochemical degassing, because for example, in Italy, we have more than 3,000 people dying every year by radon ionizing radiation. And also the geochemical content of waters or the ground is controlling also the time span that we live. So it's incredibly important to study the soil, the chemical content. We also have the space weather, the inner ionizing radiations, the mineral resources, and eventually the geothermal power. And all these phenomena are generated by some sort of gradients. So the study and application of these themes are really important in contributing for a more sustainable world. Well, geosciences may really play a high relevant role in controlling and in contributing to understand these issues in order to recover raw materials and to find new sources of energy, such as the thermal budget, the thermal gradient, which is preserved just a few hundred meters or maximum a few kilometers beneath our feet. So the scientific community has more than ever a great responsibility to provide advancements and to suggest the best practice to the policymakers. So we need to study and control gradients. What is their nature, how they evolve in steady state or catastrophic conditions. So the passion for science, that's the title of your meeting, is the engine for a better world. So many thanks. And I finish with a word by Malcolm X, who was saying the future belongs to those who prepare for it today. So best wishes for your successful meeting, and thanks for the invitation.
Thank you very much for this nice, kind word, and also for telling us in brief your contribution to this particular workshop. Okay. Now, I think I want to, before I go to the next section, I want to thank you, but also all the other speakers, because this overview really prepared very well the setting of our symposium. And I think they were all very interesting and well, and it is difficult, in particular in a very short time, to present what the relevant issues. And in this case, this was very well done. Okay, so thank you to everyone. And now I think I call here, where is Chiara Meroni? Chiara, who is in the management board of the Italian Institute of Nuclear Physics. And she will share the next speaker. Thank you very much, Chiara. Okay, this is what
Okay. So, I'm happy to be here, and I'm happy to introduce Professor Stefano Fantoni, who is from the UPAP Trieste, and will speak to us about UPAP motivation for this year of sustainability.
So, welcome everybody. First of all, let me convey you the greetings of our presidents, Michel Spiro, and the executive committee of IUPAP, which actually is the subject of what I'm going to say. But before doing that, let me really express my gratitude to this panel. Actually, this panel was really on the side of what we are going to say. Much of the issues that IUPAP is interested on are really well said and well established by this panel. Okay, so let me, as it was said, I will speak a little bit about IUPAP and the way it's structured, just because of an introduction of the missions that is behind the International Year of Basic Science for Sustainability. So you see in this picture, this is a snapshot of one of the many meetings that IUPAP is doing all over the year, General Assembly, and so on and so forth. And this is also telling you the way we are working now, mostly through remote, say, meetings. And so that is... So I'm actually just be the Secretary General for Administrative Affairs. That is because the Secretary for Administrative Affairs is now sitting in Italy, sitting in Trieste, and in particular in the foundation, the Trieste International Foundation for Scientific Progress and Freedom that I am directing at the moment. So let me just state that IUPAP, as you, I think most of you know, is the only global international scientific union dedicated to all areas of physics. So it is a sort of a very interdisciplinary organization, and it is run by physicists from all fields and continents, almost all continents. And the mission is that we want to assist in the worldwide development of physics, to foster the international cooperation in physics, and to help in the application of physics towards solving problems of concern of humanity. And I think what we have been listening just now is it very much goes into this direction. That is a slide with substantially saying the same thing, but in a more expressed, in a more say specific way, and that may part of the new plan of the IUPAP, which has been stated very recently. But I don't think I have to go very much into all these sentences, but let me again say that we want to assist in the worldwide development of physics and promote physics as an essential tool for development and sustainability. So the word sustainability is really in all the issues of IUPAP. And then you see also promote international agreements on symbols, units, and nomenclature and standards is something that we have been listening today. Let me mention, I think this is, I wanted to mention this because that is a press release that the UPAP Executive Council made on the Russian military offensive in Ukraine. And that also is because it is telling what is the mission of IUPAP. Let me read it. We are consternated by the news regarding the Russian military offensive in Ukraine and the terrible consequences that this has on the lives of our colleagues in Ukraine. We extended our deepest sympathy and solidarity to them and to all the Ukrainian people at this difficult time. We praise the large number of Russian colleagues who have been expressed their sympathy for their Ukrainian colleagues and demanded peace for their countries. In our 100th anniversary this year, I will come to this very soon, we know the critically important historical role that IUPAP has always strived to play in bringing physicists together across political divides, even during our most difficult years in the past. IUPAP continues to embrace and promote scientific collaboration across the world as a driver force for peace. So I think that is also stressing our mission. So I have a couple of slides with a bit of history about IUPAP. Everything starts in 1922. Of course, this is the centenary that we are celebrating. And it starts with William Bragg, that was the first UPAP president. And then there are the 13 first state associated to IUPAP at that time. And the group, the 10, the so famous 10, Bragg, Brivan, Corbino, I mean, I think is a very strong beginning of IUPAP. And I hope that it will continue like that. That is much more recent, but I wanted to show you this. That was IUPAP General Assembly in 1984 that was held at ICTP. ICTP, as you know, is an international center for theoretical physics. And that is one of the reasons why the Secretary for Administrative Affairs of IUPAP is in Trieste right now. On the bottom, you find a snapshot of IUPAP General Assembly held in 2022 in Trieste. And there you can see Michel Spiro, you can see who is the actual president. You can see the designated president, Silvina, is not very visible, but is there. And that is to say that we have been started already in doing it. Now the situation is that we have a 60 state member. That is how big it is, IUPAP in this moment, and that includes 4 new associations. Then we have discussing the possibility of having corporate associate, and that is discussing right now. And there are 4 regional physics society, the American, the African, the Asian, Pacific, European, as observers at the moment. And that is a map of the IUPAP member, the different colors to say about the founding members, the current members, and the new members. So you see that we are really global in that sense. Let's come to the governance. So the IUPAP is governed according to the new statutes and bylaws of IUPAP that has been adopted in a General Assembly in 2021. I'm sorry. And to become articles and internal rules as soon as IUPAP get the legal status of non-governative organization as an association under the Swiss law located in Geneva and with the administrative office in Trieste. That is the sentence which is below that picture is telling the passion of IUPAP in some sense also, because it says that, there is only a couple of people who are really working as a staff, real staff. All the other are voluntary. And so, and that is actually is telling you that really physicists are really voluntarily dedicated to these global issues. Okay, the General Assembly is substantially the highest governing body of the Union, and it creates and amends the statutes, the procedural bylaws, and elect the Executive Council, and as well as the members of its commissions, and sets the members' dues, what they have to do. But the other instrument that IUPAP has is the IUPAP Executive Council, which is a very important structure because as all the authority of the General Assembly in between the assemblies, and except for certain issues, it may also fill vacancy of the commissions. So you see, the structure that is structured in 3 different branches: the commissions, the affiliate commissions, and the working groups. So here you have the list of the IUPAP Executive Council, and so I'm not here. In the first 3 places, Michel Spiro is the actual president, the past president is Bruce McKellar, and Sylvina Pons-Dawson is the designated president, will be just coming in next year. And so here there is a list, a sort of list of the commissions. So we have 20 commissions, actually 19 commissions. And there are these affiliated commissions that you can see the list, the Commission for Optics, for Relativity and Gravitation, and so on. At the moment, we have 6 of these affiliated commissions. The working groups are, again, 19 of these working groups. Very important. All of them are important, obviously, but in particular, I want to mention the working group in women in physics. So the gender problem is an issue which is very present in all the discussion of IUPAP. And some working groups of this list have had close links with the same similar working groups at the OECD Global Science Forum. Conferences. IUPAP sponsor and endorse about 50 conferences per year, distinguishing between very large, medium-sized, and specialized. And in all the cases, keeping a lot of attention to developing countries. The requirements are obviously scientific interest and the worldwide attendance with no prior restriction, inclusiveness and diversity. Also important is the early career the attention to the early career scientists, and we give prize hours to them. We have been given up to now 192 prizes between 2006 and 2018. So we are very active on this, and the commissions are working a lot for finding out these youngs that has to be prized. As I said, gender gap is under the study, a very dedicated studies, how to measure it, how to reduce it, and particularly the International Mathematical Union lists the gender gap in science project, and so that is something which is very much under the attention of Ayuba. This is another project that I'm just showing here, this lamp, which is the using of light source and crystallographic sciences to facilitate the enhancement of knowledge and improve the economic and social condition in targeted region of the world. We have a newsletter, actually the last newsletter, it will come very soon, because the change into the secretary has made a little bit of difficulties. And now let me go to the second part of this presentation, which has to do with the International Year of Basic Science, which is more in the argument and theme of this symposium. And then you see there are many institutions which are related to this. And let me make here also a little bit of history. So the proposal, the original proposal, actually started in 2017 to the International Basic Science Program of UNESCO. There was a support from several scientific unions and research organizations, as well as ISSG and UNESCO International Basic Science programs. Then we had the resolution adopted by UNESCO General Assembly in November 2019, so to mention Jordan, Russia, Vietnam, and Nigeria. There was a welcome in the final resolution of the World Science Forum of 2019 in Budapest. And it has been supported by Interparliamentary Union and the Club of Rome. So that is just let me put as a preliminary fact, historical fact about this, but then the real proclamation by consensus was done at the 17th United Nations General Assembly on December 2021, and that was brought by that many countries that you can see in the list. So this international year is supported by about 50 international unions and organizations, by 100 science academies, scientific networks, and learned societies international advisory committee. It has 30 Nobel laureates and field medalists. And of course, there is UNESCO World Science Forum, Club of Rome, Interparliamentary Union. So the fact that we are really now celebrating this in Varenna is particularly important, I would say. And I have to, okay. Well, about the rationale, I think we have been hearing this morning already, the rationale of the importance of this. In fact, let me not go through all them, but basic science for sure are not always and everywhere considered as they deserve. in the discussion concerning the development, social development, environmental development, and economic development. That is wrong. That is actually something that we have to pull out and fight for this. So, I mean, curiosity-driven science constructs the pool of knowledge which future generations will use for their development. And I mean, all this, I think most of you know very well all this, what is written there, but let me stress again that this effort that physicists are doing for going into the direction of sustainability and inclusiveness is not well known, is not sufficiently known around, and so we have to do some effort in that. The examples of this rationale are obvious, and we have been, so the vaccine and treatment against COVID, for instance, or the web was born itself. There are many examples that testify what is this relevance about. And the tentative list of topics that we are going to, that been discussed is the basic science as a multicultural dialogue upon peace, education and human development, basic science and women, and more generally equity, diversity and inclusion, innovation, economy, sustainability, and the last one we have been listening, big science and big data. All this data revolution is extremely important, and physicists has been doing a lot in this direction, and we will do a lot in the future as well. Events. The opening ceremony will be done at the headquarters of UNESCO in Paris on the 8th of July on this year, which has been delayed due to the late proclamation, actually. And the closing ceremony will be done at CERN, in Geneva, in the third quarter of 2023. And there are a lot of global, regional, national, local events in developing countries as well. Organized or endorsed by steering committee, the international advisory committee everywhere. So what we expect from all this here? We expect implementation of open access publishing for all basic science papers, open data, and open software. We expect to promote equity, diversity, and inclusion into collaboration in basic sciences. We expect training and education to basic science in developing countries. And the connection of scientists to the actors of sustainable development. So what basic science is really doing for sustainability. And to develop basic toolkits to support science-based decision-making. That is also extremely important, as well as decrease the environmental footprint of basic science. So we want to start with a decade of basic science for sustainable development. We want to be the actor of this sustainability, but in a measurable way. Some of you have mentioned this. Sustainability is something that has to be analyzed, measured, and the source of what is happening in the future. So, you know, this is the virtuous circle that our president, Michel, is always telling us. Something that starts as, let me put it like that, it starts from basic science, it goes into discoveries, and the discoveries go into the application, as we have listened. It was, and these applications actually are ruled out by sustainability development, but that as a feedback on the basic science as well. Let me close this part, actually, which is the last part of my talk, with something which is related to Trieste in this moment. 5 minutes. Okay, yes, but I'm in time. We have been starting out say, a sustainable complex network to experiment interdisciplinarity at the service of sustainability and the virtuous cycle that we have seen before. So that is a sort of laboratory, in terms of physicists, which are developing 7 clusters. Let me put it the wording of the network, but 7 groups, as a matter of fact, more or less autonomous. And you see the issues are more or less what we have been listening today at the moment, the blue planet and the ocean sustainable economy. That is a must for Trieste, which is actually on the seashore. Food security and health of the planet and its inhabitants. Climate and environmental changes. The new data science for sustainability and human ecology. Energy transition and industrial product chains. Sustainability frames the social equity and the rights to sustainability. The sustainability is really sustainable. That is the question that we are trying to answer. And the last one is special instrument to monitor the terrestrial habitat. That was some we had listening just in the last talk. So that is starting now. We have been financed just a few months ago. And already there will be in July a symposium on human ecology that will be related to this set of sustainability frames in one side, but also to new data sciences. A second one will be done in November for relating to the food security and the health of the planet. And so we are moving in that direction and as a contribution to the cycle. Now let me finish with a few slides on the Hub Centennial Symposium that will be held from the 11th to the 3rd of July of this year in Trieste. And so here there is a list, so it's ready. I'm not telling you anything about that, but just to tell you that all the issues are, all the various speakers are contacted and everything is online. Of course, there will be the opening with the presidents and so on. There will be an historical session. Roberto Mani will come and tell us about that and many others. But you see, there will be 3 full days of physics and how physics and how science in general, more in general, is really contributing to sustainability. So that is actually what I wanted to tell you, recalling again the International Year of Basic Science for Sustainable Development. In that, on the right, you see the group of people that have been working mostly, and you certainly recognize Michel Spirot and the other president, Sandro Scandolo, who is here also, who is actually the Deputy Director, Secretary Director of Ayuba, and the people that are working with us on this management. So, what to say? You are all invited, obviously, to celebrate Ayuba centenary and the International Year of Basic Science for Sustainable Development in 2022 and 2023 by participating to and creating all sorts of events. And for the time being, arrivederci to Trieste, and see you on July.
So thanks to Professor Fantoni for this interesting presentation. And we are happy that you are celebrating our 100th centenary. And SIF this year is celebrating 125, sorry?
From the lake to the sea.
From the lake to the sea. And SIF is celebrating his 125 year, and the ENFN is also just terminated 1 year of celebration. So we have still hope of long scientific life in front of us. So I will, and also I wanted to start saying that I completely agree with your the sentence of UPAP Council about the war and about the fact that promoting the collaboration in science is a driver for peace that we have to continuously pursue. And also CERN last week has given the same, trying to continuous collaboration agreement with the Russian Federation in order to keep the door open for possible peace coming. So I open, please.
Okay, thank you very much for the nice, concise and clear talk about Ayuba. I had a question about the C16 working group about the science and industry.
Working groups?
I mean, you have a group dedicated to science and industry, so fostering the links with the industrial sector, yes?
Yes.
Which is led by Chris Russell, as far as I know. And until a recent past, IUPAP was not allowed, to recruit representatives in the industrial sector, so you changed probably your status for this. And what is the status of any representative from the industry in IUPAP?
Well, that is a sort of something which is discussing right now, right? I'm just also looking at Sandro, and that we realized after some discussion actually that to have corporate inside the management of the IUPAP was very important, and that is something that we are going to do it. Corporate member, yes. Yes, I'm sorry, I'm typically going up and down. Yeah.
Other question, comment?
Yes.
Do you know if there are new proposals for additional working group that are being discussed, or the situation is rather stable at the moment? Or
no, there are other groups that are being discussed for other working groups, yes. That is, now I cannot tell you
the status.
The state of the, but that is certainly the. You see, the work that the contribution that the working group are giving is extremely important. Of course, you have to include in all this organization. You have the commission, the affiliated commission, etc. But and so you have to give. We feel the relevance of giving a voice, more voice of what they have it now to the working groups, and that is something that we are considering.
Because I see that working groups have more flexibility to organize, to invite people, and to go through more deeply into some discussions that then are reported to the commissions. So I think this is my impression, but I don't know if
I agree with you about that. Although we insist with the Commission to go into that direction themselves as more as possible, frankly, because that is one of the duties that they have to go into this. So, but yes, you're right.
Oh, for outside. We have people outside. Okay. Yeah, so you mentioned the idea of pushing pluridisciplinary aspect or interdisciplinary aspect.
Absolutely, yeah.
And so the question may be is how many working group has been created within this vision of encouraging discipline to work together? How many of these working groups exist? And how many you could think of establishing in the future?
Well, I think that as you have seen the panorama of the IUPAP, that is already going into that direction. More specifically, as I was telling you at the end, in Trieste we have been promoting these activities, which is explicitly interdisciplinary. So in the moment we are looking at 7 clusters, 7 groups, but which I mean they are not covering all you want, but the idea is to try to mimic this network, methodology to have other clusters somewhere else and try to push into that direction. I personally believe that interdisciplinarity is something that we have to promote more and more. Because if we really, as physicists or scientists in general, we want to approach the sustainability in a real and true way, then there is no other way of going through interdisciplinarity. And so what we are trying to do is exactly what you are saying. How we do this? We don't know how to do that. And particularly, it is likely, as you might know, as you certainly know, is that interdisciplinarity is something that is to be also governed in a way, because at the moment everything goes into the direction of disciplinarity and not interdisciplinarity.
Let me see, what I had in mind more interdiscipline, like physics, chemistry, physics, biology, physics and medicine.
Absolutely.
That's extremely important.
Absolutely. Yeah. No, look, I mean, I haven't really gone into the detail of what we are doing there, but each of those groups are really made up of people that are transdisciplinary, as you might say. Now you might, I think you are mentioning this. Absolutely, yeah.
Okay, thanks. Some other question, comment? If not, thanks, I'll speak again.
We are really on time. I'm really impressed by this. Okay, so we meet at 20 to 12. So 11:40, let's say.